From 2014 through 2025, I was a Twitter user. The platform deteriorated rapidly under Elon Musk's ownership. Suggestive deepfakes of teenagers were the last straw. Does that make me an X-user or a Quitter user? I missed this on the wiki. OAM scan does not happen in prerender. Instead, it repeats sprite pattern fetches from the previous frame's last line, and those sprites would almost always be out of range. I moved more range checking logic to pattern fetch. That let me turn off OAM scan in prerender. I made sure the change worked with other games. It fixed Haunted Halloween 86, it fixed Full Quiet, and it fixed Haunted Halloween 87. With that out of the way, I turned off MMC3 timer logging and documented the interface that mappers implement. A handful of mappers, such as MMC5, observe writes to PPU registers. I don't plan on implementing MMC5 quite yet for a few reasons. It's poorly understood, not all that common, and the NestDev community discourages its use in new projects. I'd be more likely to implement TQ-ROM, a board with both character ROM and character RAM used for 2 pinball games. So I looked for other things to document to help me remember preconditions when writing another mapper. A few games, mostly by Koei, have more than 8 kilobytes of SRAM. Other games enable or disable SRAM to protect it from stray writes. A few games, such as Low G-Man, won't run properly if SRAM is present. Other games switch ROM into the SRAM window, so I needed to make SRAM switchable just like ROM. I started with reads. I checked my work using Haunted Halloween 87. This exposed another issue. Turning off OAM scan in prerender made it read secondary OAM out of bounds. Taken care of. Back to SRAM bank switching. Reading SRAM while SRAM is disabled should read open bus. I copied the SRAM bank switching logic from reading to writing and added an exception for writing to echo RAM, which often indicates a stray pointer. I made plans for the next few days and documented more functions. I made the PPU not clear status flags when the reset button is pressed. Reset is part of the difference between front loaders and top loaders. I slept on it and built a laundry list of fixes to put in. One unofficial opcode from this test was still missing, along with 2 from another test. Conventional wisdom is that opcode AB does 3 things, or register A with line noise from the data bus and the immediate value, and store the result in registers A and X. These opcodes are not only unofficial, but also unstable. I added a separate exception just for them. Though the behavior wasn't quite right yet, I could still test the exception. The exception was working. I needed to read up on the behavior. It passed. Line noise for Blarg's console must be all ones. Oh gosh, SHX and SHY. I did one of them per the conventional wisdom, and that still wasn't right. I guess I could come back to that later. 12 unofficial opcodes completely stop the CPU. They all have lower nibble too, and not even NMI can break out. I added an exception for these. The exception was working. I had the headless front-end break on this exception. The breakpoint was working. I had it trace SHX and SHY to a file that I could search through. A 212 megabyte log? I investigated what's going on in another emulator that passes. The test was running the instructions from work RAM. Once I had the address, I could search my log for that address. This gave me a log with each instance. I narrowed it down to tests with the right values in A and X. Though checksum-based tests don't fail fast, I could at least tell what addresses feed the checksum and work backwards to what gets written there. By setting breakpoints on the test and the checksum input, I could get a handle on what it was supposed to be doing, and then look for those combinations in the trace log. I needed specialized logging for this one. It's been 45 minutes just for one pair of instructions. I printed the exact data fed into the checksum to see where it diverges. The first difference was on line 10, where the third byte changes from hex 01 to something else. And we have another double header. I reread No More Secrets to see what could be causing this. It said if the target address crosses a page boundary because of indexing, the instruction may not store at the intended address. Instead, the high byte of the target address turns into the value stored. And here, page boundary crossing may not work as expected. The page where the value is stored may be equal to the value stored. I could hardly believe it. I had to see it for myself in the memory viewer. Keep an eye on address hex 300. I manually wrote a value there and it wasn't overwritten as expected. It was so foreign I wasn't picking up what was happening. I put a breakpoint on writes to work RAM at all addresses, and it showed hex 100 getting written. It took that long for the behavior to sink in. Once I added that behavior, the results matched. And the test passed, after an hour spent on 2 instructions. An exception for stack underflow was a lot quicker to make. I threw those 2 instructions from heck into a function. I never wanted to see them again. SHA could go in the bin along with them. Once I had most single tests passing and had support for MMC1 mapper, I could run Blarg's combined test ROM. And it all passed. On to finishing the stack wrap exception before I get hungry for a snack wrap. I said earlier that some MMC3 games fail if SRAM can't be disabled, so I looked up how MMC3 games disable SRAM. MMC3 recognizes 3 ranges of values: off, on, and read-only. MMC1 checks bit 4 of 2 different registers depending on ROM size. Because one of these places is the character bank register, SRAM can actually turn on and off over the course of a scan line. Though no games rely on this pathological behavior, I still wanted to keep it in mind to detect it for an exception. The smallest games completely bypass MMC1 program bank switching. I couldn't think of any test ROMs for MMC1 SRAM disabling. Test ROMs for mappers tend to be less common because they're harder to make and run. You can't just run it on an EverDrive because then you're only testing the EverDrive's emulation of a mapper. You need to actually solder sockets into an original cartridge. So I ended up coding this one without tests. Sure, I'd made Holy Mackerel a test ROM for several mappers, but because other emulators didn't pass it, I couldn't tell whether the bug was in their code or mine. Nor did Holy Mackerel fully support large character RAM. So I disabled large character RAM just for MMC1. That made it detect SNROM, but I was still getting the 4000 error for wrong SRAM disable. What other loose ends could I tie up on the 12th day of Christmas? MMC3 is unusual in having a setting to make SRAM read-only. I needed to rework SRAM mapping to support that. I felt confident that I could meaningfully pass this because good emulators actually support disabling SRAM in MMC3. Though watch out for emulators that conflate MMC3 and MMC6 because Star Tropics fans outnumber low G-Man fans. That was straightforward. I added a breakpoint for the stack wrap exception. I confirmed that Blarg's stack test covers wrapping, but when I tested the stack wrap exception, it crashed. Why is the stack wrap breakpoint calling string comparison at all? I figured I'd check for null pointers in the interest of defense in depth. The check worked, but why did it get called in the first place? Copy and paste error, go figure. And then the breakpoint worked. To make the string comparison pointer check even more robust, I had it display whether one or both arguments are null. AccuracyCoin by 100th coin is a broad spectrum test ROM. It gray screened. I counted how long it took to boot in a good emulator, 12 frames. The headless front end was accepting an invalid frame count as 0. I looked through the logs, saw it finish waiting for the PPU to warm up, and got a program address to investigate in another emulator. It was the VRAM clearing loop. It continued into another subroutine. Even though I lack debug symbols for this build, AccuracyCoin is free software with source code on GitHub. AccuracyCoin stores some addresses intermixed with opcodes. This requires a bit of pointer juggling on the stack. I added labels by matching the disassembly to the source code. I found the end of VRAM clearing. These labels would help me understand how it fills video memory, so I could figure out what was causing this blank screen. I looked for where my emulator was actually getting stuck. AccuracyCoin was waiting for a sample to start. My emulator doesn't have sound yet. I tried sorting opcodes by group again, but I didn't run regression testing often enough, and I had to roll back 12 minutes of work. I put that off until Epiphany, which is tomorrow.